Alright, square root basics. Alright, before we start square root, we want to start with perfect squares. That's what this is. This is 2 squared. This would be 3 squared, 4 squared, and so on. So what is 2 times 2? That's 4. We know that's 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. And the reason you need to know these is because of square roots, it's the reverse. They are inverse operations. And what the square root is asking you is what positive number times itself. That's what this wants to know. What positive number times itself will give you 4. So the answer is 2. All of these are questions. Square roots are commands. You're going to multiply 2 by itself, 3 by itself. Square roots are the reverse. They're asking you what was it? What was the question before? So what were the 2 numbers that you multiplied to give you 25? 5. Good. 6. And these are nicely set up, so you can just finish them right on down. 7, 8, 9, 10, 11. So the next one was 144, which is 12. And that's it. Square roots just want to know what number was being multiplied by itself, what positive number. Alright, here's some other ones. We have radicals with negatives, with fractions, with order of operations. If there is a negative outside the radical, then when it's our little leading negative, you just transfer it. And so the answer is negative. And then what was the square root of 64? If you need a hint, look up. It's 8. That's it. If you have a decimal, then what you do is you count the number of decimals, which is 2, and then you divide them in half. So 1. So the answer would be 0.8 negative. That's it. So if we had this 0.0009, sorry about that, 9, there are 4 decimals, so that means what's the square root of 9? 3. And since we had 4, the answer is going to get 2. And that's it. So if you have a decimal inside of a radical, you split the number of decimals and give that to the answer. If you have a fraction, you're allowed to split it, to separate it. Numerator with numerator, denominator with denominator, which gives you 8/5. So what would this one be? You got it. -1/2. The leading negative you carry over. Square root of 1 is 1. Square root of 4 is 2. If you're doing order of operations are exponents. So radicals, these are exponents. So we do groupings first, and radicals can actually group numbers as well, like on the second one. But we have groupings. There aren't any, because this is just one number and one number inside the radical. So you move on to do exponents. Well, what is the square root of 81? 9. And there's an operation between that radical and here, and since it's not given, it's a multiplication. Square root of 1 is 1. -6 times 9 is -54, plus 5, and then we have to add them, so -49. So we did our exponents, and then our multiplications, and then our addition, and then that is your answer. Alright, so give the next one a shot. Remember, use the rules. You want to do your groupings first, which is your radicals. Well, these are actually one number now, is how we're treating them. But you want to do your radicals first, then your multiplication, if there is any, or division from left to right, and then your addition or subtraction from left to right. So hit pause and give it a shot. And there you have it. So square root of 25/9 is 5/3. The square root of 64/81 is 8/9. And then you need a common denominator, so we create a common denominator, and then we can now subtract them. Alright. Approximating using your calculator. And what I meant to say is approximate without using your calculator. So if you want to know what square root of 11 is, you have to just think about what that number, what all our radicals actually are. So if you come up here, we have them all. Square root of 25 is 5. Square root of 16 is 4. Square root of 9 is 3. So if we have square root of 11 down here, it's going to fall into between square root of 9 and square root of 16. These are our perfect squares. Square root of 9 is 3, square root of 16 is 4, which means square root of 11 must be approximately 3 point something. So we can say that it's about 3, because 11 is closer to 9 than it is closer to 16. That's all I need, is just that number 3. It gives you, if you say square root of 11, I don't know what that is, you can say, well, it's about 3. Square root of 52. I want you to look at that one now. So go back, look at the perfect squares that we have. Find the two perfect squares that the square root of 52 falls in between, and which one is it closer to? And then write that. I want to see about what? Hit pause and try it now. So 52 is between 49 and 64. Square root of 49 was 7. Square root of 64 is 8, and 52 is closer to 49. So we would say it's about 7. It's good enough. So square root of 52, and it's about 7. It's 7 point something, basically. Just like square root of 11 is going to be 3 point something. Watch, if you take out your calculator and you look at it, let's do square root of 11. See, 3.31. You notice it's less than 5 because it's closer to 9. And then if we do square root of 52, we said that one's about 7. And there it is, 7.2. So, thank you.